Here we have a function. It looks like a cubic function, and we're told that it has x-intercepts. That means where it intersects the x-axis of -3, 7, and a y-intercept where it intersects the y-axis of -63. So we can find these points on the graph. So that's this point, that's that point, and that's that point. So let's label those. So that's 7, -3, and -63. And we're then told that the area enclosed by the graph y equals k multiplied by f of x is 500. And they want us to find the value of k. So before we do anything, we're going to have to try to find f of x, or try to estimate f of x from the given intercepts. Then we'll look at the effect that multiplying by k has. So because this is a cubic function, and we know it's a cubic because it has the characteristic cubic shape with 2 turning points. So we can guess that f of x will look something like this. And it looks like we have one point where the curve cuts the axis, and one point where the graph touches the axis. And the difference between cutting and touching is that when it doesn't intersect the axis, when it touches the axis, that's where you have a repeated root. So what you probably have is something like this, where this will be x plus 3 and x minus 7. So the x minus 7 refers to this point, and the x plus 3, and this tells you that you have a repeated root. So that's your repeated root where the graph touches the axis. So we think this is probably what our graph looks like, although there could be some constant. It could be multiplied by some number. And to check that, we look at the y-intercept. So the y-intercept, that's when x equals 0. So we try putting in 0 here, here, and here. So f of 0 is equal to 3 squared times -7, and that's -63. And that's exactly what we're given here. So that means that our guess was right, and this value here is just equal to 1. So we can now use this as our f of x. Okay, so that's our f of x. Because they're looking for area, we're going to need some integration. Before that, let's try to think about what does multiplying by k do. So when you multiply a function by k, that's a transformation. What kind of a transformation is it? Well, when you multiply by k, if k is positive, that'll result in a scaling or a stretching in the y direction by a factor of k. Okay, so when you multiply by k, what that does is it stretches your curve by a factor of k. So if you multiply by 2, then it'll be twice as big. If you multiply by half, it'll be half as big. So this is a stretch or a scaling in the y direction by a factor of k. But because we're told that k is negative, then multiplying by a negative number has the effect of inverting or reflecting our function. So it's reflected in the y-axis. So our graph will actually look something like this, where it's been reflected and it's been scaled. Now we don't know if k, the absolute value of k is less than 1 or more than 1, so we don't know if it's been made smaller or bigger, but we know that it's been reflected. So this reflection is because k is less than 0. So they're saying that this area is equal to 500. So this area looks like it's going to be this, the area between the axis and the curve. And to find the area, we need to integrate. So your area would be the integral between these two limits, between 3 and 7 of f of x. So that's the first thing you do. You say the area under k f of x equals to 500 between minus 3 and 7. Now, the purpose of this is to find k. So my unknown here is k. What I'm trying to do is to find k. So the first thing you need to do is replace f of x with what you know f of x is. So f of x is that function there. Now you can't integrate that because you've got multiplication, so you need to expand these brackets. So you need to carry out the multiplication, so x plus 3 times x plus 3 times x minus 7. If you multiply it all out, you get this. If you collect the squared together and you collect the 9x and the 42x, you end up with that. And if I've done that correctly, then you put that in your integral. You still have the k, that's a constant. You can take that out of the integral, that's fine. And then you have something that looks like that. Now that's easy to integrate. You know the limits. It's a nice simple function. We can integrate that, and that should give me a number. So that integral of x cubed is x to the power 4 over 4. X squared is x cubed. So this is easy to integrate. Then you simply substitute 7 into each of these, and you substitute minus 3 into each of these, and then you subtract. I did that previously. Stick it all in your calculator, and it'll give you these two numbers, this for the 7 and this for the minus 3, and there's a minus between them. Now that will give you a number, and then you just divide 500 by that number, because the total area is equal to 500. So if I divide this by that, you get that. You can put that in your calculator, or you can just turn this division into a multiplication and then simplify that, and it gives you a negative value for k, and that's what we were expecting. We were expecting a negative value, and it turns out k is equal to minus 3 over 5. So that's your final answer. So the way we approached this was to first try to estimate our function, guess the function from the x-intercepts and the y-intercepts. Then we'd try to figure out what the integration was. We'd had to expand the brackets, We then had to insert the k. We made that area equal to 500. Then a little bit of integration, and then some numerical manipulation. It gives you your final value for k. I hope you found this explanation helpful.